Colour. We're going to start by looking at colours in the real world. So the spectrum that we get when we split light with a prism or in a rainbow, the colours are always in the same order. So if we use the imaginary scientist name RGB Revision, that allows us then to make sure that we've got all of those in the correct order. So when we look at our RGB colour model for computers, they are still in that same order. So we always start with our red. We're not going to worry about orange and yellow, green, blue, and then we've got the indigo violet. So we're going to use these three colour channels to represent colours on a computer. So this is called the RGB colour model. So there are different colour models used for computers, for monitors, for televisions, for printing and so on. RGB is probably the most common one used. Red, green and blue are the primary colours for light. So in order to look at this, let's imagine that we've got three huge spotlights. We're all sat in a cinema with the lights off, so we're all in the dark. Each spotlight has got a dial on it going from 0 to 255. So if it's 0, you've turned the light off. 255, it's as bright as it can be. We turn all of the spotlights to full, and then we're going to move them so that the circles of light overlap with each other. So at this point we can see where the circles of light overlap, we then get different colours. And the colours should always be brighter than the three primary colours because we are adding more light to them. So here's our colours. So we've got our red, green and blue primary colours, and we've got our cyan, magenta and yellow secondary colours. If we mix all three colours, we get white light, and if there's no colour at all, where things are switched off, then we get black. So at this point you need to load up the O1 RGB Colours 1, answer the questions. Pause this video, load up the colour triangle that you've got in your folder if you need to do, and then when you've completed that, come back to the video. So now we're going to have another look at this colour triangle and start looking at some of the RGB values. So each of the RGB values goes from 0 to 255. For primary and secondary colours, and for white and black, we only need two numbers for each channel, which would be 0 or 255. So let's start by having a look at what the RGB code for red is. So up here, where we can see the red is on full, so that would be 255. Now let's look at the green channel. The green channel is this circle here, and if you notice it ends there and does not come into this area for red. So that means that the green value is 0, because there is no green needed up here to make red. The blue channel is this circle of light here, and again, when we're up there in the red, none of the blue is coming up here, so its value is 0. So our RGB value for red is 255, 0, 0. And that's what we expect, because red's a primary colour, we don't need any other colours to make that colour. Let's have a look at the RGB code for yellow. So we can see yellow in this area here, and we can see that yellow is inside the red circle of light. So it must be 255 for the red channel. Yellow is also inside the circle of light for green, so it must be 255 for green. But yellow is outside this circle of light for blue, so the blue value must be 0. So our RGB code for yellow is 255, 255, 0.